Okay, hiya. So this video is about 4.6 and it is about finding a tangent line to a function using a derivative. So I have a couple things already on the screen, and I thought that one, you should know what a tangent line looks like. So this blue line here on the screen is the tangent line. Okay, so it is a linear equation. Remember that those are in the form y equals mx plus b, where b is your y-intercept and m is your slope. And hopefully you remember some things about linear equations: slopes rise over run, uh, y2 minus y1 over x2 minus x1, those kinds of things. Also, we're going to be using the point slope form of an equation. Form of a line is y minus y1 equals m times x minus x1. When you're given an ordered pair, x, y, you're going to just relabel those as x1 and y1, and you would put them in here along with a slope that you would know and turn it into y equals mx plus b form. Okay, so the function you're going to be given is going to be a rational function. It'll look like this red function on the screen in the graph. Okay. You're going to be asked to find a tangent line. So I thought that it might be handy if you knew what it looked like, A, and what it is. So over here, a tangent line to a function is the line that matches the function's direction at a specific point. And that's the idea here. You're going to be given a specific point, the x1, y1. So it says, imagine you're driving on a curvy road. At any instant, your car is pointed in a particular direction. If you froze time and drew a perfectly straight road extending in that direction, that straight road would be like the tangent line to the curve at that point. The tangent line tells you which way the function is heading right there, how steeply it's increasing or decreasing at that point, and the function's instantaneous rate of change. For example, if a curve passes through a point and it's rising sharply there, its tangent line will also rise sharply. If the curve is flat at that point, like the top of the hill, the tangent line will be horizontal. So there's some real life application to the tangent line. We haven't spent any time doing linear equations here. That was earlier in Algebra 2 and Algebra 1, so hopefully you remember that stuff, but we're going to go back to that. So like I said, I wanted you to have an idea of what that looked like. And then I'm going to have you at the end of these problems go to Desmos and graph them, which is where this graph came from, and so that you can see that you did the problem correctly. Okay, so let's go and do one of these. There are a few steps in these problems. They're a little bit long to do one, but once you know what's happening, I think you'll be all right. Remember, I'm going to just do one of these because they are a little bit time consuming so that the notes aren't terribly long. But just take your time, turn things off, pause me if you need to, make sure you know what's happening. Okay? All right, so here's the example. All right, find the equation of a tangent line to the function f of x equals x plus 1 over x minus 2 at the point 4 comma 5 over 2, period. Okay, so step one. And you don't have to label these per se in your notes, but I thought it would be handy if I labeled them so you kind of had a very specific process. You're going to find the derivative of f of x using the quotient formula. Okay, so we've done this a number of times. We're going to call u of x, x plus 1. We're going to call v of x, x minus 2. We're going to call u prime of x 1, and v prime of x is also going to be 1. And then we're going to multiply v of x times u prime of x. Excuse me. So f prime of x is going to be u prime of x times v of x minus v prime of x times u of x all over v of x squared. Okay, so let's plug some things in here in a different color. So we're going to multiply 1 times x minus 2. So that's just going to be x minus 2. And then we're going to subtract off 1 times x plus 1. So that's going to give me a negative x minus 1. Okay, so I don't like to worry about my denominator too quickly. So I'm going to have x minus 2 minus x minus 1. So this is going to be, these are going to cancel, and I'm going to have a negative 3 over v of x, x minus 2 quantity squared. Okay, so that is my f prime of x. That's the first thing that we need, okay? So let me put that in a box. I'm going to go to step 2. I'm going to put that at the top of the page, okay? Then I'm going to go to step 2. So let's go to, so my f prime of x, well, let's do this. I'm going to need the point 4 comma 5 over 2. And we know that f prime of x is 3, or it was negative 3. Yeah, it was negative 3 over x minus 2 squared. Okay, so step 2. Use the given point and plug the x part of the point in into f prime of x. So in this case, we're looking for f prime of 4, right? So that's going to be negative 3 over 4 minus 2 squared. So you're taking this 4 and plugging it in for any x in f prime of x, which is why this notation would be the best way to do that. Then I'm going to simplify. Negative 3, 4 minus 2 is 2, and I'm going to square that. Negative 3 over 4. And this value becomes your new slope in the tangent line. Okay, so that's an important, this piece is going to be important moving forward. Okay, so now what we're going to do is use point slope form. I guess this would be step 3, technically. Use point slope form of the line, which is y minus y sub 1 equals m times x minus x sub 1, where the point you're given is x1 and y1. And we know the slope is right there, right? So we can go y minus 5 halves is equal to m, negative 3/4, times x minus 4. And be careful with your signs, right? If either of these x1 or y1s were negative, because the formula is negative, make sure you change these to a positive. So we'd have y minus 5 halves equals negative 3/4 x plus 3. When you multiply these, right, this would be 4 over 1. The 4's would cancel. You could do it in a calculator if you have to. Now we're going to add 5 halves to both sides. And that's going to give us y equals negative 3/4 x plus, when you add these together, right, this would be 3/1. You need a common denominator, so 6/2 plus 5/2 gives you 11/2. You can do that longhand. You can stick it in a calculator. You can use Desmos, whatever you want, as long as you get the right number. Okay, and this is in y equals mx plus b form. This is the equation of the tangent line. Oops, there you go. Equation of the tangent line. And so I am going to highly encourage you to go over to Desmos and type these into Desmos so that you can see that you've got these right. And the two things that you would be typing in are the original function, so f of x is equal to x plus 1 over x minus 2, and the tangent line. Okay, so I'm going to show you where I've already done that. It's actually the same picture that you had earlier. So I'm going to go back to Chrome over here. Here's your Desmos. Okay, so if I were to, here's the function, the original one. Don't put f of x. Make sure you put y. If you put f of x in here, I don't think it'll work. Oops, f of x. Oh, it does work. Okay, so that's good. You can also put nothing and just put x plus 1 over x minus 2, and that will work as well. Notice the colors over here correspond to the colors on the graph, right? I don't know how much you've used Desmos in the past. And then the blue, y equals negative 3/4 x plus 11/2, is the tangent line. And you can see that there's a point over here, and if you hover over the point, you have 4, comma, 2.5. Well, 2.5 is 5/2, and that's the point that you were given originally. So they have to be, that's where the tangent line was supposed to cross through the curve. So you can also see if you get your equation wrong and you maybe get 9/2, it doesn't hit the curve, right? And so that's not a tangent line because it's not hitting the curve. Or you type it wrong and you get a 1 instead of an 11. Well, that doesn't hit it either. Okay, so maybe your sign is wrong. Maybe, you get 11/2. And that is also not a tangent line, right? It crosses through the curve, but it doesn't actually hit the curve. So there's a couple of examples of what it's supposed to look like when you get it right. Okay, so there you go. When you get into varsity, there's only a couple of questions, I think, at the end on here. Find an equation of a line. There you go. Find an equation of a line. All right. This one, equation of a line tangent 2. I'm looking at number 14. Okay. So it tells you x equals 2. Well, that's an equation of a line, right? So here, I'm going to pop back to, we'll just kind of bring this up over here. So what that one said was, I have this in my notes on a totally different page. Don't ask me why. All right, so I'll go to a different screen here. So real quick, what this said was that you had find a line tangent to the line x equals 2. Well, remember that this is a vertical line, right? That goes through the graph at 2. So this would be the line x equals 2. True. So you could actually, your any point on this line, x literally is 2. So in step, let's see, let's go back. Step 2 here, where you use the given point to plug the x part in, you don't have to use a given point. You can use f of the value they give you, right? Because 2 will be anywhere on that line, and that will help you find your slope. Okay. And then you can do a couple creative things from there. So let's see how creative you are or if you need some help with that problem. Okay. If you get stuck on it, you can skip that one and go to the bottom two. They're exactly like the ones I did in the notes. And then come and see me about that one. Okay? All right, one more section in derivatives, and we're done with the class where we all are doing this together. And I've probably already talked to you in class about making a choice from here and continuing with the algebra track, which is what the normal rest of the class has always been. I'm kind of splitting it off this year, or choosing a trigonometry track. And no matter what you do, either track, you're going to have to join a new Google Classroom. Sorry for the writing. My screen is like straight up in the air and it's really difficult. And a new varsity class. So a choice has to be made one way or the other. You're also going to get a new packet of handouts. So if you have no idea, if you do not like, if you're not really interested in trig, um, don't want to move forward with that. And this is not, we're going to start with right triangle trig, but then it moves to unit circle trig. So it's the trigonometry that you'd see in a pre-calculus class. So this, it pushes you a little bit. It's what you'd see in college level classes or at the beginning of college level classes. It's what used to be in my pre-calc class when we had one here, but we don't anymore. And I feel like some of you need this class if you're going on to take any kind of pre-calc and calc in college. So if that's something that you think is for you, you might want to jump into this trig track. If you have no idea what you want to do and you're fairly decent with algebra, you may want to just stay in the algebra track. But either way, you have to make a choice. There's not just sit where you are and just kind of slide right along. You're going to have to make a choice. So new Google Classroom, new Varsity Classroom, new packets of handouts, no matter which choice you make. But that will happen at the end of chapter 4 in our post test. Okay? All right. Toodaloo for now.